Hello everyone, I hope you all are doing well. This side Priya Bhatia, and in this video we will be starting our project where it's kind of a dummy project, you can say, where whatever things we have learned so far with respect to k-means, whatever mathematical intuitions we have understood, that how internally it will work, how we will be able to find out the optimal number of clusters, everything today I just want to demonstrate you practically. So let's get started without wasting any time. So I hope that you can clearly see my screen, right? So what we will do is we will try to work upon the e-commerce based data set, and we will try to do the implementation of k-means on top of this. Now you can see that there are separate code blocks that we have. Please try to understand each and every bit of the code and the logic behind what I'm doing here, right? I will try to showcase and run the files with you in the live itself, and we will see the results, how we are getting it. Okay? The only purpose of writing the code prior to the recording itself, so that it won't take much, I'll not spend much time on writing the code. Instead of that, while doing the recording part per se, I will spend more time in order to explain what is the motivation behind doing that part. Okay, so let's get started. First of all, you can see that we are dealing with some data file. What is that file? Maybe again you may have two options. First option is maybe we can try to upload the file which we are referring here, or maybe we can connect to a drive. So I will try to refer a second option, because on my drive itself, with the name of hands-on k-means clustering, there is a folder where my data is available. So let's try to connect the drive, and now you can see there is a drive option which is available with us. Now if I'll go inside this and we'll go to the machine learning course part, there is a module 3 by the name of unsupervised, and here you can see not this one, by the folder name hands on, we have data.csv file. Maybe I'll try to copy this path and I'll try to paste that path over here. Oh my god, there is a lot more, but let's see whether we will be able to get the correct result or not. Anyhow, the first step we all know is to import all the required files. So let's import that. So you can see I'm importing NumPy, Pandas, Matplotlib, Seaborn, which is usually required for every particular project that we have done so far. Apart from this, you will observe here in machine learning, we have a package named sklearn.cluster, where all the clustering techniques that we will study in future as well is available. So the only work which we have to do is to import that. For example, today's target is to implement k-means. So I have already imported k-means here. Now, you all know how we will be able to read a CSV file. I have specified the path. Now, in this case, you will observe I am also specifying a delimiter. Can you see this? Delimiter is there with a comma separation, because we have a file in which comma is the separated one. So I am specifying that. Apart from this, you will observe there is one other parameter called as encoding. This basically helps us to read the textual data. That's why we are specifying this kind of encoding. Okay. After that, in terms of getting maybe top 10 records, we will have to use the head, and inside that we will specify the numbers. If you will not specify, by default you will be able to get the topmost 5 records. Let's try to see this, whether we are getting a similar results or not. So here you can see we will be having invoice number, stock code, description, quantity, invoice date, unit price, customer ID, and country. Now you know what's the second task which we're supposed to perform, right? Data reading part is done. Now we have to somehow understand the data. We have to somehow do the preparation of the data and EDA task. So let's work upon that part. So let's say I want to get the information of entire columns that we have. So there exists a function by the name of info. We already have discussed about this as well, where it will be containing the information of all the available columns we have. How many non-null values are there? So you can see somehow there exist somewhere the null values also. The count is there, the D type is there, data type is there. You can see apart from quantity, unit price, and customer ID, every particular column which we have is of object type, right? So let's try to understand the description of this data. Now you can see .t function. If I'll just remove this and if I'll just try to run this code, you will be able to see this kind of description will come, right? Where in the y-axis we will be having, or I would say in the row part, we will be having count, mean, standard deviation, minimum value, 25 percentile, 50 percentile, 75 percentile, and maximum value. And in the column side per se, we will be having the quantity, we will be having the unit price, we will be having the customer ID. In order to make it look good, you can also do a transpose of the metrics. I hope you already know the concepts of transpose, right? What is the meaning of transpose? Whatever rows you have, that will become your columns, and whatever columns you have, that will become your rows. So if you will run this code again, you will be able to see transpose matrix is there, where if you remember in the last matrix, we will be having in columns quantity, unit price, customer ID. Now it is available in my row part, right? So quantity is there, unit price is there, customer ID is there, and the stats measures that we have, descriptive stats, which I usually say, is available here. Now, in this case, you can see, I hope you all are aware till so far, that whenever by default we are calling this describe function, it will always gives us the description of the numeric data, maybe of int type, maybe of float type. But let's say I'm looking forward for the description apart from the int and float. So in that case, I want to look for the description of non-numeric features. So how can we do so? Maybe you have to specify that I want to exclude specifically int and float, because by default, this is what you will be able to get at any point of time whenever you're applying this describe function. Always remember, by default configuration will be, it will always give us numeric data description. But let's say I'm looking for non-numeric one. In that case, you have to specify that I'm not looking for this int 64, I'm not looking for this float 64. Give me the description apart from these two types. And then we will do the transform of this. So you can see, once you run this code, you will be able to see the invoice number, you will be able to see the stock code, description, invoice date, country. So whatever be the count, unique, top, frequency, so whatever be the non-numeric features we should have as a statistical measures in a descriptive part, we will be able to see it very clearly here, right? Now the next important part is to check the null values. So here you can see we have description null values as 1454 and customer ID, which is 135080. By the way, this particular data set is from UCI repository. I will show you as well UCI repository. So maybe you can refer this repository, which contains a lot many data sets, and these data sets are the actual data. So this, I will share the link also for this data set, which you can download. So it's a complete e-commerce data set from UK, if I'm not wrong. So you will be able to see they have recorded the sales which they are doing in a way, what is the unit price, what is the customer ID, what is the quantity. And what they want is ki, as per the customer requirements, as per the customer needs, we want to do the, in a way, grouping, right? So it's a dummy, you can say, project of customer segmentation only. Full-fledged end-to-end we are doing at the end of the course. But here I just want to showcase you how the flow will go, right? So this is how the things will look here. Now let's move ahead. So we can see that there exist a null values, right? If we just want to see the shape of the data, you can see it's a very huge data, contains 54,000 approximately records, not 54,000, 5 lakh records. 5,41,909 to be precise. These many number of records are there and 8 number of columns are there. Now, one thing which you will observe very carefully here, that in this particular data, we don't have specifically a target column available with us. Can you see that? Right? So target is not available. That's why it is a part of a non-supervised or unsupervised machine learning, right? If you remember, whatever projects we have done so far in the supervised machine learning algorithms per se, in every kind of a data which we were dealing with, we were having a target column available with us. In this case, it is not there. That's identification that whether we should go for clustering techniques or whether we should go for standard, supervised machine learning techniques. So now let's move ahead. I hope until this part everything is clear. Now what we can do is we can drop the null values which is available for now, because we have a huge amount of database, right? Almost 5,41,000. So you can say 5.5 lakhs records are there. So if we can remove 1 lakh also, it doesn't make much difference because the data size is very huge. So as for now, I'm deleting all the missing records that we have. Now here you can see there is a parameter called as in place equals to true. So when you're manually writing this parameter as true, what it will do is it will actually try to store the results in your data, right? If you will not mention it, inside data, the changes will not be reflected. You have to either make an assignment operator, like data is equals to data dot drop NA. Otherwise, you can make in place equals to true, so that it will actually reflect that changes in the data itself. So let's run this. You will be able to drop all the missing records now. And here you will be able to see now our shape automatically gets reduced to 4 lakh approximately 6,829 records. So now if you will just verify, you will not have any sort of missing values. So one problem for now we have solved. Although there can be more optimized ways to solve that. Let's say you want to do the imputation, right? Or you want to somehow mapping, you can check it out. But as for now, I think this seems great to me to move ahead. So here we just have to we have handled it via dropping all the missing records, right? Now let's check whether there is negative values available in the data or not. So if you will be able to see inside the data, so this is where you can say we are trying to understand our data in a appropriate manner. You will observe that we will be having negative quantities as well. We will be having negative quantities available with us. Maybe these are the cancelled orders. So this C indicates a cancelled order in a data. So you can observe that, okay, people usually, let's say I'm ordering from Amazon website. We have a habit, if let's say we are not having a great product, so what we usually do, we usually cancel that product. Maybe we can have a quantity of 12 or 24, we don't care if the product is not great. So that is where we have cancelled products. So maybe for now, I'm not looking for those values which are negative. Maybe in future when we are doing further projects, we may look upon that depending upon the business scenario, depending upon the requirements. Maybe if they're saying that you have to analyze the cancelled orders as well, we can do so. Maybe we can verify that what can be the reasons for the order cancellation. Specifically for data analysis per se, I think this cancelled orders makes a lot of sense, right? Because we want to analyze the data to justify that people are cancelling the orders because of what reason. So that company can work upon those reasons in order to make a huge amount of revenue, in order to reduce this cancelled orders. But for now, because we're not doing the analysis of data, but our focus is to analyze the segmentation of the customers, so maybe I can remove that part as well. So you can see here, I'm just checking it out, the unit price also, less than 0. How many records are there? There is not any record as such. So what we are doing is we are trying to drop those quantities which are having value less than 0, and then in place equals to true. You already know what is the meaning of that. So in a way, when I'm trying to remove those records also for which the quantity is less than 0, we will left with almost 4 lakh records, can I say? It's like 3,97,000. So approximately you can say we will be having 4 lakh records now. Now, you will be able to observe that we will be having a value of quantity, which is positive now. We will be having a value of unit price, which is positive. We have already checked we don't have a negative unit price values. So why not to create a separate column which indicates total amount, or you can say it indicates sales. Can I say so? Right? What is the sales? Sales is nothing but the quantity into unit price. That is what you can refer it as sales. So maybe you can say one thing. What you can do here, you can try to create a new data in which you are grouping as per the customer ID how much sales they are trying to generate. So what we are doing is we are trying to do the addition of sales, and we are trying to reset the index from 0. So by default, whatever the customer ID we will be having, as per that, we are trying to create a new data which indicates customer ID uniquely defined, because we are doing a grouping. So grouping uniquely defines those customer IDs, and the sum of total sales each customer is doing. So if you will run this code, you will be able to have 2 columns with us for every customer ID, how much total sales customer is doing. That is a very important column for me, because that itself indicates that how much is the spending power of each and every customer we do have, right? Let's move ahead. So here, if you will just see the type of this new data, let me just check it out and show you. So just wait for a moment. I have mentioned it wrongly. Type of new data. So you will see, as for now, this is a data frame. So we have data frame with the name of customer ID and sales. This is one data frame that we have, which makes a lot of sense, and it is very, very important. So in a way, we are trying to create a data. So this is a part of data preparation cycle, right? Second thing which we will do here is, if you can see, just calculate the total number of transactions every customer is doing. Because if a customer is doing more transactions, means his or her spending power is again higher. So let's try to check how many number of transactions customer is doing. So how can we check that? First of all, we will try to again do the grouping as per customer ID, but now with the count of how many invoice number they are generating, right? Because this invoice number will be able to give me an indication that how many number of transactions every customer is doing. And again, we are trying to reset that index. So now again, we will be having a new data frame by the name of num_trans. So if I'll again show you, not this block, maybe here I can say the type of this num_trans, you will be able to understand that this is a data frame that we have. Make sense? So here we will be having two data frames now. First data frame is somewhere new_data, where we will be having the customer ID and the sales, where every customer, for each customer, how much is the total sales we have. That is what the indication is all about. Then we will be having the number of transactions with the count of how many number of invoices every customer is generating. Make sense? Now, let's try to understand the last important thing, which is the last transaction which a customer is doing. So how can we do that? Now we will be having this invoice date. Can you see it's kind of a timestamp that we have, which they have recorded in their database. If let's say I will convert that into to_date time. So what will happen is, let's try to understand. So we are trying to convert this timestamp type to date time. So what will happen is, now if I just show you again this data of invoice date, and you can check how will it look like now. So now you have converted into a date time. So if I'll just show you the above part, how it was there. So it was like this. Can you see? It was like this, where we will be having slash kind of a things. What we have done is, we have appropriately convert our type to date time now. That's why it is looking like this, because it's already ran that file. That's why it is showing appropriate manner. So now we have tried to convert our invoice date from that slash part to this way, where we have the current date plus time. Now we want to evaluate the last transaction customer is placing. So how can we do that? So what we can do, we can calculate what is the maximum value, means last date when transaction happened, minus the current date that we have. Now if I just remove this part, and if I just show you what does this looks like, right? So let me just try to show you this part first of all. So you will be able to observe, we will be having number of days, and we will be having again the timestamp, right? But what I'm looking forward is the number of days only. How many number of days, like maximum invoice date minus the current date. So how much is the span? For example, 373 days. It is looking like that, right? So I'm looking for only days part, right? So in that case, I will try to convert and fetch that days only. So that is where we have mentioned .dd.days. Now if I'll just try to show you again, our data of last transaction looks like days only. So it will just capture the days now, because that is what we have specified here. Make sense? So now if you will just try to see here, your data looks like this, right? So we will be having last transaction available with us in a data itself. Now what we will do is, we will try to do a grouping, because we are doing a last transaction. As per that, we will be having customer ID and country, and we are saying whatever the maximum last transactions we are getting, just try to take that number. So what we will be having is another data frame, where we will be having the customer ID, we will be having the country, and the last transactions they have made. So you will be able to observe that it is 325 for a customer ID 12346 and UK. So what will happen is, now grouping is done with respect to customer ID and country. It might happen that they have customer shift to some other country and then they have a transaction. So we will be able to have a data of that as well. Make sense? Now let's move ahead. What we are doing is, we are trying to merge all the tables now. So here you can see, if you are aware about the concepts of inner join. So what we are doing is, last transaction data frame that we have, and if you remember number of transactions database that we have, we are applying a inner join there. After that, again, we're trying to merge the two tables. One is this table, which is just now we have merged, and one is new underscore data. Again, we are trying to do the inner join as per the customer ID. And that is where our data is ready now. In the data, we will be having all the important columns available with us. In the actual data, there is no as such important columns which are there. Now we have actually customer ID, we have country, we have transactions, we have invoice numbers, and we have sales also available with us, right? So now what we can do, we can work upon EDA task where the first task is to remove the outliers. So what we can do, we can try to create the, box plot for the invoice number, for the last transactions, and for the sales, right? So what we can do, we can just see the box plot. Now we can see there are outliers available in our box plot. So what we can do is we can just apply the concept of IQR. We will try to evaluate the upper limit and lower limit, which is also called as upper whisker and lower whisker. And we'll try to create a new data frame with respect to that specific range. So again, you will observe, okay, we have removed that. We have now sales available with us. So what we can do is, instead of mentioning that total amount, we are mentioning sales here. So you will be able to see we are left with very small number of records now, which is 3923. So these are the records which are outliers, Why? Because these are the records which are either above the range of upper limit or below the range of lower limit. So what we can do is we can just take only those records are under this no df new df underscore IQR. So now let's try to see the records again. Maybe we have to change this sales part again. And now you will be able to observe somehow we have reduced the outliers. But again, there can be other ways also. I will again say, I think in the previous sessions, I have covered up multiple ways of how to handle the outliers. Maybe you can use the approach of quantile as well, right? In order to handle that. Even in this case, you can see we are left with 3,923 records now, which is quite less as comparable to from where we have started. Okay, for the clustering per se, it is fine, but definitely we need to handle the outliers in a much more appropriate manner apart from this first approach that we have covered up. Here you can see, yes, the records that we have below the lower limit and upper the lower limit, only those records we are taking up, right? And we're trying to store it inside new underscore df underscore IQR, which is approximately 3923. But definitely in future, you can work upon further approaches that we have covered up in the previous sessions to handle it in a more efficient manner. Now we are trying to reset the index of this particular new df IQR. Now we are trying to see the correlation coefficient heat map to check whether there are fields which are having a higher correlation coefficient, which is not available in this case, right? Which is not available in this case. Now I'm not covering up those concepts in a great detail, considering that you already have watched my previous end-to-end project videos, and these EDA things are actually same only. That's the only reason. If you still feel that there is some concept where which you are not comfortable, please refer my previous projects. You will get an understanding why I have not covered up repeatedly again in a great detail here. Okay, now normalization we are doing so that we will be able to avoid the biasness. I always say we have two methods to do that. One is via standard scalar, another one is via min max scalar. So here I am doing via min max scalar. So you can see we are trying to convert and scale it. So again, the only problem is the sales part, because we have changed our name. So maybe we can take sales here. So you can just try to apply sales here as well. Now I think it should work perfectly fine. So now we will be having a scale data, right? We will be having a scale data. So now you can see specifically I am working upon the numeric points, because country is something which is I would say categorical feature, right? Where we will be having a different classes, or not classes, the country names I would say, right? So this I can't include to scale it up. How will I scale these values, right? So what we can do is we can try to first of all scale the values, convert that into a scale df, and then maybe we can add a new column which is country here. Make sense? Now once it is done, this is where important thing is coming up which must be new for you. So until so far, whatever things we have covered up as a part of EDA, I believe you already aware of, right? And maybe you can do it in a more optimized manner on your own pace as well, if I'll give you the time as well, right? The important thing of this session is the clustering technique that we are trying to learn here, which is k-means clustering, which we want to do, right? So here you can see what we are doing is we are dropping the country value overall, because that doesn't contribute much as per the clustering part. What we are looking for is the number of counts of invoices which the people are generating. What we are looking for is the last transactions that they have made. What we are looking for is the sales value, the numeric three columns that we have. So we can drop that. After that, I'm using this yellow brick dot cluster and I'm importing one package, one function, k elbow visualizer. If you will go and check out this particular documentation, you will be able to see this key elbow visualizer implements internally the elbow method, which help data scientists select the optimal number of clusters by fitting the model with a range of values for k. So what will it will help you to do is it will try to give you this kind of elbow line, which you can see. So what you are saying is, first of all, you're applying that k-means, which you already have imported in the first go. Do you remember sklearn.cluster? You have imported that k-means model. You are using that model. Once your model is ready, you are saying that my value of k is in the range from 1 to 11. So give me a line, give me that elbow line, that this, you can see this elbow line, right? Dash, 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 dash line. Give me that line with the help of this k elbow visualizer function that we have. So now here you can see you're trying to fit that value in the data frame underscore k, which is your value that you have. And then you're trying to show that. So here you can see this line indicates that your value of k is 3 with a score value 173.235. By the way, on the y-axis, this distortion score which you are seeing is a WCS only, which we have learned in our previous videos. Within cluster, summation of square. So don't get confused with this term, that what is this new term they're indicating to us. It's nothing but WCSS. So whatever calculations we have done, same calculation is going on internally. And now you will be able to see how optimally with the help of this elbow method, my result is showcasing to me that the value of k should be 3 in this particular data set. It means it is trying to divide into 3 clusters, 3 segments of customers as per this data, right? Now, if we will move ahead, what you can do is you can make the predictions of this df underscore k, store it in the y underscore predicted variable. And what you can do, you can try to create a separate column by the name of clusters and you can showcase that. So what you will be able to observe, okay, we have not run this file. Let's run this first of all. So can you see? We will be able to get the value of k as 3. After that, let's try to run this part. So can you see now we will be having a separate in a way classes available with us or a target cluster which is available with us. So either it is 0 or it is 1 or it is 2. Can you see? 3 clusters division happened, right? This is the purpose of k-means clustering or in a way clustering algorithms. It is basically help us to give us optimal number of clusters by using that elbow method. And after that, we can simply make the predictions and we will be able to store it in a separate column if we want, just to showcase that how the predictions looks like. Now, if you want, when you are saying 3 clusters are there, it means we have 3 centroids. Do you remember the algorithm? So what I told you, initially it will try to internally create those 3 values, 3 centroids it will pick. Then it will try to calculate the distance, Euclidean distance. Whatever the nearest points are there, those points belong to those clusters of centroids. Again, it will take the average and find the new centroids. And this will keep on repeating until we reach to a value where the stability is there, where the clusters changes are not no more there, right? So in this case, you will be able to see we will be having 3 final clusters with us having the XYZ value, right? Because we are having 3, clusters available with us. And also we are dealing with 3 X's, 3 features. Country, if you remember, we have deleted, right? We have dropped it. So we are left with only 3 columns, 3 dimensions are there. Acha, the lesser the dimensions are, better your model will be, right? Don't increase your dimensions. Just check it out. Whatever dimensions you feel will not make much sense while making the cluster. it would be a better idea to remove it, right? So now here you will be able to see, because we will be having three columns. So it's a three-dimensional value which you will be able to get, or three-dimensional data you will be able to achieve. 3D, right? XYZ value you will be able to get. If let's say you are saying that Priya, I will be having, let's say, 7 features when I'm doing a clustering. So definitely you will be having those 7 points. It's very difficult to for me to make you visualize those 7 points or 3 points also. I can only visualize the two axes, X and Y. That's what I had done in the previous sessions. But I think you can imagine the third axis which is there at the back side if you can. Okay. Now the last part is the model evaluation. This thing we will cover up in the upcoming class. By the way, this model evaluation is being done via something called a Silhouette score. Now, I usually like to first of all explain the mathematical intuition behind the concepts, then the practical implementation. So today I am not working upon how this code work is doing internally. First of all, in the upcoming video, I will help you to explain the internal intuition behind Silhouette score, how it is helping me to understand that, whether my clusters are good or bad, right? What is the optimal score it looks like? We will discuss everything. Then maybe we will be able to understand this implementation also. That's the last step, which I'm, not implementing here. I'll show you in the upcoming session, in the upcoming video. So stay tuned for that. So now I hope that you will be able to understand the internal intuition behind K-means plus the practical implementation for the same. The last part which I had left in this video is the model evaluation with the help of Silhouette score. So in the upcoming video, first of all, we will try to understand the again internal intuition behind the same, and then I'll show you the score for the project that we are doing in this particular video. So you will observe that actual ending for this project which we are doing today is in the upcoming video only. So please stay tuned in the next video, where we will first of all talk about evaluation metric for any of the clustering methods that we have, followed by the implementation for the same. So bye bye everyone. See ya.